I mean, yeah, and I my flight to Poland is until the 27th. And I thought there was a being the new member, I can't say too much about it. Yeah, no, but if it's someone where I'm not like having to deal with that was not having some form of responsibility.
Oh, really? Oh, you fucking go? Yeah, not the new bag.
Just like that. Yeah, usually. Well, there's a handful of like CS and I mean, they should. Who needs to learn that? That's enough to break into it.
Come on. Come on. I'm just I heard a lot of you also have 30 people.
I got one guy. And I got in contact with him and said, hey, you told me you actually you're going to sponsorship with it. And I was like, yes. And he's sitting in the shit for like 2 hours.
Alright, cool. Let's get started for this week. Yeah. Quiet down. Alright, cool. So, welcome to week 2 of RC3. If you're a new member, welcome. Glad to have you. Got this new clicker, it's so awesome. Alright, so this week we are streaming. Woo! It's the first time we've ever done it, so please don't yell any bad stuff. We have a YouTube channel, so if you ever go on call for anything, just go to our website, click the YouTube, it'll take you straight there, and there'll be a Boxing live stream, and then you'll be able to see us and be with us in spirit. So this is kind of happening. It's not quite done yet, but we hope to have it working by next week. Academic Cloud, for those of you who don't know, RIT runs my courses. So every 2 to 4 years, they buy new hardware, and that hardware just sat in the corner. So now they're like, hey, we should just power all this on. So that's what they did. They made a big data center, and now they're giving this type of computing power out to faculty and students. So RC3 is going to get it, so we're going to be putting all our demos online. The only thing you have to do is go to this website, rc3club.ret.edu. You'll log in, and then the demo should be there, so you can do it from home. So right there in your web browser. It doesn't work yet. Don't try and log in. It won't be ready until next week. The reason I'm bringing it up is we need you all to sign up on this Google form so that I can give you access so that you guys are ready to go by next week. So if you can go find this presentation, which I'm going to put in after I'm done going over it, if you guys can sign up, we'll have you guys ready to go for next week. Cool, so we have some clubs here with us. So we're going to have next top go first. So we have a bunch of clubs here in Jesus. I invited them all here to kind of talk about what they do so that you guys are aware of what they do. And we're one big family here, so you don't just have to go to RC3. You can go to any club here in Jesus. So.
Hey guys, I'm Brent Wolf. I'm the president of Next Stop. And
I'm Steve. I'm the vice president.
So Next Stop is the Networking System Administration Club. We meet every even Tuesday up in the Net Lab from 7 to 9. We usually have pizza, so that's a nice thing to have. So, like I said, we do networking system administration. Usually we do labs every week, and they'll tie into either networking or system administration. We also have tech talks. Those will be scattered in throughout the year. We'll just have someone from the industry or a professor come in and talk about what they do or something they like. So yeah, I know you guys are going to be working on networking stuff today, so if you like what you're doing and you want to continue that, you can come to our club. You You can join our mailing list at nextstop.network, and you can start doing that stuff from us. Yeah.
And we have a competition in the spring, N6, so start thinking about that as well.
Yes, N6 stands for Networking System Administration Infrastructure Competition. So it's teams of 4 and 5. You build a corporate network in a weekend, and basically it's a race. Yeah. What's up? Cool. Thanks, man. Yeah.
And we meet every Wednesday at 6:30 in room 2455. We're an all-inclusive group and want to make Dallas Conroe a bigger community. So we have companies come and speak to us, we have different committees, and feel free to join anything.
Yeah.
we have a bunch of events, and it's really great.
I'm part of it.
Community. I'm Chris Gray. I'm also from the computer science community. I'm secretary. So what we do is we hold a bunch of computer science or computer science related workshops. We've had stuff on the new Linux shell and like Bash and stuff.
We had that yesterday.
And then we've got board game night next week. And so we do fun events as well.
We're doing board game night next week. So again, we're totally into like
Collaboration.
yeah, whatever.
Synergy.
Yes, synergies, everything.
But yeah, so we do educational events and fun events, and we try to alternate those week to week. So keep an eye out for us. Website csc.cs.red.edu. Sign up for our mailing list for for getting updates on events every week. So
We also have cute little cutout cards, which has like contact information and what we do. So if you're interested in taking these, I have a bunch of them, and I don't want to recycle them because they bad for the environment or whatever. So please come take them. Thank you. Oh yeah, I'll look up for you. Thanks.
Everyone, Chris Lau. I'm president of Localhost. And Localhost is a relatively new club. We've been around for 3 years now. And Localhost is a web design development club. We have semester meeting 1 to 3 times a week. Our weekly meeting, we have a tech talk where we invite any, we host our own tech talks, and we invite any club member to present a new web technology, a web design trend, the rest of the product. Our other gatherings include workshops where we teach range from very basic HTML, CSS, output to maybe more advanced topics like frameworks like AngularJS, React, or maybe advanced CSS techniques, responsive mobile design. We also invite people to show their own projects with the club. So if you want to get feedback, critique, or help with a project or a personal project, school project, whatever, you come and we have some super games for that day also. We also have a semesterly competition called Design by Design, where we give you a web page, designs already made, but then you have to put it up and see that it's not picking your progress. We just in the past have made $25 on gift cards, and that's about it. Our meeting room changes from week to week. We alternate Thursdays and Wednesdays at 6 p.m. And you can sign up at our website, localhost.com.
Hey guys, so I'm Scott. I was the captain of last year's CCDC team. You guys don't know what CCDC is? It's the Collegiate Cyber Defense Competition. We're not a club, we're just a team. So pretty much what CCDC is it takes a team of 8 and we go up to some college or some campus and we place drones in the infrastructure that simulates a medium-sized company, and we defend it all weekend while professional hackers try to attack and take down services. It's a lot of fun, so I encourage you guys to try out. Let's see, this year the regional competition is going to be held at RIT, so come be a part of the team that defends the home turf here. Let's see, tryouts are gonna start next Friday at 5 o'clock upstairs in the Sec Lab. If you guys have any questions, please reach out to me. And if you are interested, please click the form there. I'm gonna post the link also, in the RC3 Facebook page. So, fill that out so I can get you an email so I can send you out more information. Awesome. Thanks.
So I'm just going to go over some quick news and then we'll move straight into our presentation for today. So this is kind of a cool new developed tool by a famous Android developer / hacker. He created this thing called woooo. So there's this API in Android. Does anyone have seizures? Because had seizure problems taking flash. Anyway, sorry. So they have this safety net API. What it does is when you run certain apps like Android Pay, it'll run this API to see if root's enabled on your phone, because by default it's not. If root is enabled, it won't allow you to run that app. So what this woooo does is it hides the root part of your rooted device from that app, so you can still use Android Pay in apps like that. So that's kind of cool, and I thought that was really genius. So, you know, people are always trying to get around these things, so I thought that was interesting. So if you all didn't hear, Dropbox got hacked, but not recently. The data breach actually happened back in 2012, but actually we just got confirmation that it actually did happen, and it was close to 68 million accounts were compromised. There's actually a 5 gig data dump that's currently being passed around the dark market as we speak. I tried to look for it, couldn't find it, but it's currently being passed around. It's actually has like a pretty hefty price tag on it, but they didn't say how much it was, so this is going around. It is SHA-1 hashes, so that's something we're going to be talking about in 2 weeks what hashes are. But for those who know, SHA-1 is kind of insecure at this moment, and we're starting to move to more secure hashes that are harder to brute force. I love the irony of this picture. He stole 2.9 million credit cards, but he has it in his hand. Love it. All right, so there's a famous lawmaker in Russia, and his son was actually stealing credit cards, and it was actually really controversial about his father trying to help him out, and the Secret Service over in Russia was trying to like seize his laptop. And he actually went through and actually destroyed his laptop before they actually got their hands on it. So he was like tampering with evidence and stuff. So it's a really controversial case in Russia right now about how to handle this, especially because he's kind of like a minor and all that. So that's really fun. He was stealing information from Seattle pizzerias. Pretty interesting. Retailers and U.S. businesses around the globe from 2008 to 2014. So he was stealing credit cards for a long time, and no one caught him. So until now, which is pretty scary to think that someone went on the loose for close to 6 years and no one caught them. So just to put that in perspective. So. All right, and then we have the two U.S. state elections systems got hacked. So they're not confirmed, but they have some plausible evidence that they can say that the systems were hacked. It has some kind of brute force attempts with SQL that they can kind of link that someone was trying to. There's some skew in the data that they can try and see that someone was trying to mess with the data. So this happened in 2 states. One was Illinois, and I think the other one was Arizona right here, as reported by Yahoo News. So with these 2 places, they told them to update it. So, you know, this is pretty scary because we just had the DNC attack. So a lot of people are attacking the voting systems, which is really scary because it's part of our democracy. So something to keep in mind that these endpoint systems that we don't really think about are getting attacked all the time. And they think it was Russia. Speculation. So, all right. So this week, we're going to do an intro to networking 101. With our Professor John Wiseman. He's awesome. I freaking love his class. If you have a chance to take it with him, definitely do. He's an awesome lecturer. So he's going to give you a breakdown of networking and hopefully about 20 minutes, maybe a little bit more than that. And then we're going to move into NNAP and some DDoSing stuff. So I'm going to put up the screen and let him take it away.
day, a few families moved into the neighborhood that my family and I live in Brighton. And my wife and I actually met a few of them in Wegmans, and my wife made a care package for one of them, and she said, "Here, Jonathan, give this care package to the Smiths." So on our block, you know, houses go up for sale every now and then. So I saw the for sale signs and the sold signs, and I wasn't quite sure which house Bob Smith lived at. He was the one that we were taking a liking to. There were some shady families, we didn't want to associate with them. So she said, "Give this package to Bob Smith." And it was late at night, I wasn't sure which house Bob Smith lived at, so I took out my amplifier, my microphone, and I shouted on the top of my lungs, "Hey, Bob Smith, which house do you live at?" It pissed off everybody in the neighborhood, woke up our two little kids at home. My wife was like, "Jonathan, what the hell are you doing?" And I said, "Well, I just got to get Bob Smith's attention," and I did. I got the attention of everybody else on the block, but I did get Bob Smith's attention, and he came over very discreetly, and he said, "Hey, idiot, it's 123 Main Street," and then walked very quickly back to his house. That's story number one. Story number two, my wife made this nice care package for her parents. My in-laws live in Pennsylvania, and she said, "Here, get this to my parents." I wasn't about to drive to Pennsylvania. I had an 8 a.m. class the next day, like I do every morning here. So I get this. I took the box that she made for her parents, and I brought it to the nearest UPS store, and then I had UPS delivered to the next UPS store, delivered to the next UPS store, and it got there as well. So those stories are kind of true, but they illustrate the decisions that hosts make when they have packets, pieces of data to transfer to other nodes. A node is a fancy way of saying anything with a logical IP address that we're going to only talk about briefly today because I only have 20 minutes or so. Anything that needs expansion, you know where to find me upstairs. It's the office door with a lot of pictures on it. So in story number one, I determined that Bob Smith and his family, who we want to be friends with, were in a relatively close vicinity to our house. If there's any traffic that a node has for that network, local traffic, the node actually delivers it himself. No need for no stinking router in that case. But in the second story, where I had a package to deliver to Pennsylvania, I wasn't going to drive to Pennsylvania. I was just going to bring it to the nearest UPS store, and that UPS store would find the next UPS store. That's how routing works for UPS, USPS, DHL, as well as internet-based routing. So let's take a look at a very simple example relating to what we talked about. Let's say there's a host with the following IP, Internet Protocol, logical address of 10.0.0.1. IP addresses in the world of IPv4. I guess I'm going to come back for IPv6, we'll do that another time. But IPv4 addresses are 32 bits long. And we call each of these numbers an octet because I'm writing it in the base 10 notation that we love, but in reality everything's binary. So each one of these four numbers that comprise a base 10 dotted decimal representation of an IP address are really the cover for the 32 bits or the 8 bytes, the 4 bytes that live underneath in base 2. So if I was to transfer this into base 2, it would look something like this. Can you see this colors? Is this color? Yes, no? That's 10. That's 0. That's 0. That's 1. Columns go from right to left with values of 1, 2, 4, 6, 1, 2, 4, 8, 16, 32, 64, and 128. And you keep going, but we're talking about a specific byte or an octet that IP addresses are comprised of. The IP address by itself is worthless because there are two portions to an IP address. The first portion is known as a network ID. The network ID is the string of bits at the very beginning of a logical IP address that's shared by everybody on that network. The second part of an IP address is known as a host ID, a unique string of those 32 bits at the end that represent a pattern unique to every node on that network. So the obvious question is, where is the breakup? There used to, in the early days of IP addressing, starting from January 1st, 1983, which was Flag Day, when we actually flipped the switch to go to TCP/IP instead of the old NCP protocols. That's a story for another day. There was a time where we had this system called class full addressing. 20 minutes, I'm not going to even touch that. We've been classless since about 1991. Somebody stopped me on the street and said, are you a classy person or a classless person? In a networking sense, you're very classless. So that's the way you're going to answer that. So the entity to identify which bits in the IP address are network bits shared by everybody in the network and which bits are host bits, a string unique to all nodes on the network, that thing is known as a subnet mask. And the subnet mask consists in binary, like the IP address, of ones and zeros, but here's the pattern. Subnet masks always start with ones, a string of ones, consecutively, and always end with a string of zeros, consecutively. There's no mixing or matching or anything in between, because a 1 in a subnet mask represents that the corresponding bit in the IP address is a network bit, shared by everybody on that network. A 0 in the subnet mask means the corresponding bit in the IP address represents a host bit, which is unique to all nodes of the network. So for this particular example, where the IP address is 10001, I'm just going to use the following subnet mask of 255.0.0.0, which means everybody on this particular network shares the same 8 bits at the very beginning, but the last 24 bits can oscillate based on the assignment, whether it's from a DHCP server or some static configuration. So let's fill in the rest of these zeros. There might be 8 there might be 7 or 9, but let's just pretend that there are 8 over here to save some time, because I only have 20 minutes. Now, we're going to do a Boolean AND process, which is what the transmitting station does to determine whether communication is local or remote. If I said, stand up if you're a man and you're wearing a hat. I could stand up. All the other men with hats. Yeah, go ahead, what the hell? Stand up if you're a man and wearing a hat. Notice that no women are standing up, and also notice that men without hats, that's actually advantageous, are not standing up as well. Because these guys fulfill both of those criteria. So the way, okay, great job. The way that this works in the world of Boolean math is that you've got 2 inputs. The 2 inputs of 1 produce a 1 on the output, because the AND logic says if the first bit and the second bit is a 1, produce a 1 on the output. Every other pattern produces a 0. I'm sure you guys are going to be looking at other types of Boolean logic like XOR, which is used a lot in cryptography, but that's coming up. So now, what I'm going to do is I'm going to line up all of the 32 bits of the IPv4 address and all of the corresponding bits of the subnet mask, and I'm going to bring down a 1 in all the columns that have 2 1s. And it's going to look like this. And all the rest are zeros. You can't have 2 1s if you got 24 zeros going in the last 3 octets. Translated, that becomes back in our friendly base 10, 10.0.0.0. What's the purpose of this? Well, the transmitting station says my IP address is 10.0.0.1, my subnet mask is 255.0.0.0. I want to know what network I'm on. That's my network ID. In other words, when you do this Boolean AND process, and you take the IP address bits and the subnet mask bits and you do that Boolean AND logic, what results is something known as the network ID. And this is a very important concept. The network ID, the network number that identifies the network as a whole, not specific to any host, will always, no matter how long the host portion is, will always have all zeros for the host portion. And the way this network is set up, the first octet is a network octet, and the last 3 octets are host octets. That's why the network ID looks like this, so 10, 0, 0, 0. So the destination in this little story over here happens to be a node on the same network, Mr. 10.0.0.2. 10.0.0.1 wants to send traffic to 10.0.0.2. In step 2 of the algorithm, he does, again, another Boolean AND function. And we could spare the binary details and cut right to the chase in base 10 over here. He realizes the destination is on the same network. Because 10001 logically ANDed with the mask gives you the same network ID as 10002 logically ANDed with the mask. At that point, the source knows that the destination is on the same network and handles the data transfer himself. He actually says, as a network broadcast, "Hey, Bob Smith, what's your house number?" And since it's a broadcast in the form of protocol that you can only use when you're 65, or actually that's 2 A's. This stands for Address Resolution Protocol. That's going to be me speaking on my microphone and amplifier, waking up everybody in the neighborhood for the sole purpose of getting Bob Smith's attention. And I got his attention, and in my story, Bob Smith didn't shout back to me. He didn't want to get blacklisted in the neighborhood like I am. He walked over very discreetly to me and said, "It's this number over here, 123 Main Street." When an ARP request is sent as a broadcast, it's always followed with an ARP reply, because what am I really asking in the world of networking over here? I'm asking for that device's layer 2 address, known as the MAC address, the Media Access Control address. You need actually 3 addresses for the source and 3 addresses for the destination to actually send traffic. So now I am able, as Mr. 10001, after I get the layer 2 MAC address, to send traffic directly to this destination. Really briefly, MAC addresses are written in hexadecimal notation. There are 12 hexadecimal characters. The first 6 always represent the manufacturer of the NIC, the network interface card, although they haven't been cards for many years. They're really chips, but people say network interface cards. The last 6 hexadecimal characters represent a serial ID assigned by the manufacturer. So in reality, the split is always 6 plus 6. In other words, the MAC address is always 12 hexadecimal characters long, base 16. You always know where the first part begins, and you always would know where the second part begins. So that's why MAC addresses don't have any of this subnet mask concept going on. It's always predictable. In the world of IPv4, we don't know where that delineation is. That's why we need the entity known as the subnet mask. So that's story number 1. I'm able to communicate with the actual destination of my network directly. After he gives me his MAC address, I use his destination MAC address and his destination IP address to actually send the traffic to him. But let's say I have traffic for my in-laws in Pennsylvania. Let's say the IP address is 11001. When logically ANDed with my mask, 11000 is not the network ID that I have over here. That triggers me to say, wait a minute, that's too far for me to deliver myself. When you're talking about networking traffic, you never communicate directly with nodes on different subnets. You only communicate directly with nodes on the same subnet as you. So how does it get delivered? Well, I brought my package to the UPS store in the example, but what this guy does, Mr. 10001, is he also sends an ARP request. He's looking for a MAC address, but he sure as hell is not looking for the MAC address of Mr. 11001 because that's on a different network. The internetworking devices that connect networks all around the world are called routers. Switches connect nodes of the same network. Routers don't connect nodes. Routers connect networks themselves. So if I wanted to deliver a package to my in-laws, I'm not going to go find the UPS store that services their zip code. What I'm going to do is I'm going to find the UPS store that services my zip code. My UPS store, the one on Elmwood Avenue in Brighton, New York, is my default gateway. It's my way out of my network. It's the place I bring all packages to that I can't deliver myself. And when a node is configured with an IP address and a subnet mask, it will also be configured with a default gateway, which is a fancy way of saying the router interface on your network responsible for taking all traffic off of your network. So in that case, an ARP is still sent, but the ARP is not looking for the MAC address of 11001. The ARP in this case is looking for the MAC address of whoever this guy's default gateway is. The traffic is sent to the destination MAC address of the router, but the destination IP address of Mr. 11001. The router gets the traffic and says, yes, that's my MAC address, but no, that's not my IP address. The router consults his routing table to find the next router who should get the traffic. And again, the process continues. The MAC address is always the next hop, like the club. And the destination IP address is always going to be the final destination. Another good movie, a lot of movie references over here. See final destination? That's layer 3 addresses, the time I need before I get to layer 4. And we talked about layer 2 addresses being MAC addresses. We talked about layer 3 addresses being IP addresses. Technically, those numbers at layer 4 are a form of addressing. What does that mean? Let's say there's a server running many different services, DNS, DHCP, some authentication going on that server as well, an FTP server. When I send traffic to a destination IP address, well, how does that traffic magically go to the FTP server on that machine, or the DNS server on that machine, or the DHCP server on that machine? And the answer is this addressing found at layer 4, found in either a TCP segment or a UDP datagram. This addressing comes in the form of a port number. So let's talk about some basics first. Let's say you're a bit, you're a 1 or a 0, and you're going into a computer system. Physically, how do you actually get into the system? It's through the net. Through the network interface card. That's how you get into the system. But now you're into the system. Okay, from a software perspective, how do I actually communicate with the program or service that's running on that machine? And the answer is that thing called a port. A port is a number that's assigned to a program or service when it's started. A lot of people incorrectly say firewalls can open ports and close ports. They do nothing of the sort. Firewalls never open ports. Firewalls never close ports. Firewalls filter ports, which means they mediate which traffic goes in and they mediate which traffic goes out. Let's say you wanted to come to the meeting today and there's some big burly guy at the door over there and said, sorry, you can't come in unless you're wearing an orange shirt. That would be a firewall filter. The port is open, this door is open, but you're being blocked, but some other guy with an orange shirt will be able to come in. Firewalls are not opening this port or closing the port. When you start an Apache web server, when you start a FileZilla server, those corresponding ports that these programs listen on are actually started. So the way physically into a machine from the bits perspective is through the NIC. The logical way into a machine is through a program. A program that runs independent of a logon is called a service or a daemon. That's the way the bits actually make it to the corresponding services on the destination machine. That's how they actually leave as well. The way to close a port is to stop a service. The way to open a port is to start a service. So one final thing about layer 4 over here. If you're using guaranteed, and you know the way I like to say this, people tell you there's 2 guaranteed things in life, death and taxes. I beg to differ, there are actually 3. It's actually death, taxes, and TCP, Transmission Control Protocol. And he's got a real picture about that. So what I'm talking about right now is a layer 4 protocol that's used called TCP for guaranteed connection-oriented communication. The alternative is UDP, User Datagram Protocol. I want to focus on TCP because that's going to lead you to a brief introduction to port scanning. If, you know, we can do this. Here, how many markers do we have? Oh, no. That's UDP. Where they... I need it for the next demonstration. Oh. That's fine. UDP is you send it. If they get it, they get it. If they don't, they don't. Services like DNS, DHCP, and especially VoIP, voice over IP protocol, those services don't need the additional overhead that TCP affords. But if you're doing a file transfer, if you're doing an email, if you're doing a website, this is where we agree to slow down the communications to get it right, because one bit that's out of whack could corrupt the entire message. So I don't have any, I do have duplicates. Let's try this. What's your name? Yaffer? Hi, I'm Jonathan. Can I give you some markers? No. Just say yes. By the way, what he's actually illustrated is a port scan. Maybe we'll do that with you in a second. But he said yes, and now I gave him a red marker. So you say back to me, hey, I got a red marker.
I got a red marker.
So I just sent him a blue marker. Let's wait just a little bit longer for him to tell me you got the blue marker. That's all I can take. He didn't tell me he got the blue marker. Let me just try that again. That's TCP. Where every bit sent is 100% acknowledged. That's why TCP is said to be a guaranteed delivery. And in my net services class, we actually started that today, we're going through an entire packet trace for a website where every bit that I send to the web server is acknowledged, and every bit the web server sends to me is acknowledged. And we'll learn next week in terms of what happens if there are problems. So as far as TCP goes, how do we start this whole synchronous guaranteed acknowledgement process? It starts with something called a three-way handshake. In the TCP header that you can easily see as clear as day in Wireshark, the process is known as SYN, SYNACT, and ACT, where the side initiating the communication, in my little example, the web browser, says to the web server, I want to send data to you. And the way it does that is it raises one of the flags. That just means it puts a 1 in that bit position. And raises the SYN flag and says, I want to talk to you. Let's say my imaginary sequence number is 63. The way the other side, the web server, says, okay, you can talk to me, is it adds 1 to the initial sequence number sent by the source and raises the ACT flag. Source says SYN 63. The destination, step 2 of the three-way handshake, says ACT 64. The ACT corresponds to the SYN. The 64, which is X plus 1, proves that the destination really received that initial sequence number. At this point, the source can send to the destination, but that's one-way traffic. It's like eastbound traffic is closed on the thruway, what westbound traffic is not. That's actually what we call a head-open connection, a very big vulnerability. I'm sure you'll see that at some point this semester. But for now, in addition to the ACT flag and the X plus 1 value being given back to the source, the other side wants to be able to have bidirectional communications as well. So in addition, the other side, the RIT web server in this little example, sets the SYN flag to on, comes up with its own little sequence number. Let's say it's 8 in this case. In reality, there's 32-bit values, or 4 bytes, and easily sniffable in Wireshark. It's at this point that the guy who started this original communications pathway says, let's rock by sending the ACT flag and adding 1 to the 8 to bring it to 9. So really the pattern is X, X plus 1, Y, Y plus 1. And now this is an open bidirectional communications pathway. And after this three-way handshake has been established, both sides start talking to each other, and they start incrementing those numbers by the actual sizes of the TCP data. So that if the data is not acknowledged with the expected numbers, the source assumes that it was lost and sends it again. That's how it's guaranteed delivery. So if you are a machine, and I want to know what services, what programs you have running on your machine, for the purposes of finding vulnerabilities associated with those services and exploits associated with those vulnerabilities, I'm going to want to see what ports you have open, because those ports are going to be proportional in most cases to the actual services that are running. So the way a port scan works is, there are many of them. I only have time for one to conclude today. I'll show you something called the SYN scan, playing right off of that three-way handshake. The source, in this case you can actually call him the attacker, is going to send a SYN scan to a destination on a certain port. the destination, if that port is open, will send, of course, as we saw in the three-way handshake, will send the SYNAC back. But the source at this point is just performing reconnaissance. He doesn't want to actually open up the three-way handshake connection. He doesn't want anything being logged on the destination application. So what he does is he sets another flag called the RST flag, or the reset flag, which basically means, I'm done with you, get out of it. Never mind, psych. And it's at that point that we know that that particular service on that particular port is up and running. But if the destination machine does not have a particular service associated with the port being scanned, it will not send the SYNAC back, it will actually send its own RST back. When you get an RST back, the way that Vince Cerf designed TCP, he was here last year, one of the highlights of my life, meeting him and shaking his hand and looking at his brain, because all the stuff comes out of Vince Cerf. Anybody was here for that momentous occasion? All right, he comes back pretty frequently, so if you miss it, he'll be back again. So I actually told him, when I teach port scanning in my classes, sometimes I explain like I did today, and the students will ask, well, why do closed ports send an RST back? Why? What's the significance of that? And I was telling Vin last year, my answer is always because that's what Vin Cerf wanted. He cracked up. And I said, okay, can you just give me a little bit more background on why you decided it to be like that? And he talked about timeout values. He didn't want connections opened up for a long period of time. There was no need to communicate over those pathways, over those particular ports. So that's why he decided that all closed ports, when faced with a SYN, will always respond with an RST. There are a bunch of other flags. How am I doing on time? I think I'm actually right on time, right? Love to come back, invite me back, come see me in my office, but have a great day for now.
Does anyone have any questions real quick? Just want to make sure we open it up.
When we are doing the code scan and we send a SYN packet, no way that the code is open, the service is closed. Is there any way that we can get in the system?
Well, sure, there could be a netcat listener opening up on a port associated with a specific service. I do this sometimes to fool students. Do a port scan, and I open up a netcat listener on port 23, and they're like, oh, Weissman's an idiot, he's running Telnet. But in reality, I'm not running Telnet, I've just opened up a netcat listener instead.
Faster. Good to know. Perfect. So let's just finish up our presentation here. So, what is scanning and enumeration? So the first part you're going to understand is enumeration. It's discovery of hosts and devices on the network. Detecting local devices, networking devices, and things of that nature. So, scanning, finding all the available UDP and TCP network services that are currently running. If they have an open port, hopefully we'll find it. And then do some service fingerprinting and identification along with network scanning. So Nmap, it's a scanning tool. There's multiple scan types, which we'll get to in a little bit. Easy to use, flags to grab more information about a certain host or the network that you're trying to scan. It has a scripting language. Hence the red text. I'm warning you all now, it is highly illegal to scan a host that you do not own or have explicit permission to scan. It is like going around to houses that you do not own and trying to open up the door or the window. That's crazy. In the internet world, it's about the same thing.
All right, so don't do it. It's also against RIT policy to do it. They will catch you. They're looking for people.
Slight correction on that. Scanning is actually in like the kind of gray area. Technically, it's legal. It could be violation of people's policies and principles. So definitely don't like go and scan the government, because you will have people in like black suits come up to your house. And then like if you're an RIT student, don't scan RIT stuff while you're on their network, because you know it's their network and they know how to get to you. So just be smart about what you scan, but you can scan this. Just be careful of what.
Yeah,
people's
different
rules.
states have different rules, so it's better to go with it's always illegal and then do your research from there.
Yeah.
Start with it's always illegal and then do research.
Like everything we do, make sure you have permission so you don't get people in black suits coming to your doorstep.
So I know this is a little overwhelming, but we always have this as a resource to kind of go back. These are the different types of scans that you can do with NMAP. So we have our standard scan, you can run it against the host and it'll come back with all the ports that are open. Really cool. And then if you tap on the -SB command, it'll say, okay, these ports are open and these are the services that are running on these ports. It's really important if you want to do like pen testing and stuff like that to find vulnerabilities / exploits and stuff. And then you have a stealth scan, which I'm going to get to in the next slide, how that works. And then we have OS detection, which would be kind of cool to detect what kind of operating systems are running on the network if you have an exploit for an actual host. Operating systems. You're able to scan specific ports. So if you do the -P and then COM all these types of ports, it'll just scan those. If you want to scan all the ports, you can do -P-. Really useful. People don't really know that one, and they spend all this time typing 1 through -65,535. So just do the dash, saves you time. You can do UDP scan, which is not enabled by default, so you got to do the -SU command. And then a slower scan is with the -T3. So the 3, there's actually integers between 1 and 5. 5 being the fastest, 1 being the slowest. Now, because devices will catch you doing NMAP scans, the slower you do it, the more chance you have of not getting caught. So if you're trying to be stealthy, you probably want to do T1, but it'll probably take a really long time, but you'll get there. And then if you're doing really impatient, you can do --min rate and then just set it to like 1,000,000, and it'll just send 1,000, like millions of packets all in like 1 second. It's really great when you're in the pen testing class and everyone else is scanning. You're like, I want to get it done now. So it's really fun. Ryan knows what I'm talking about. So. Yes, you can. You can concatenate flags and all that. So, and then for later in our demo, just so you know, for port knocking, you do --max -retries = 0. All right, so how NMAP stealth scan works. So when we use the nmap-s uppercase S command, what we do is we send a SYN packet to the server on a certain port. That server replies with a SYN ACK, but then we don't send an ACK. We send a reset connection. So that closes the connection on the server end. Now, what makes this really stealthy is this connection is not logged. Now there are programs to catch it, but typically in logs this does not show up. So that's why it's a stealth scan, because it's not a full TCP handshake. Good on that one? Want another explanation? Any questions? Cool. So, banner grabbing is a technique of grabbing service messages from network services and network devices to see what's running there. So again, you get all the services, you find out what version number they are, you can go on Google, type in that service and the version number that's currently running, and you can find vulnerabilities and exploits, or how to use that service if you've never encountered it before. So you can use Nmap to do that, or you can use a netcat to do that. So if you do netcat-u, you can do a UDP. If you just do the regular netcat command, it'll do a TCP connection. If you need to do it to a web server, you need to actually send it an HTTP request, and then it'll reply back. So port knocking. So port knocking is a lot of fun, and you guys are actually going to get a chance to do it today. So port knocking is a method of like trying to hide a port that's actually open, but during an initial nmap scan, it won't show up as open. So what does that mean? So we do an initial nmap scan, and it doesn't show us that port 21 is open. So what do? We do a scan on port 80. Then we do a scan on port 22. And then we do a scan on port 21, and now it's open. Make sense? Good?
How does scanning the other two open up 21?
Yep, so scanning in this sequence opened up 21. So it doesn't always follow the sequence, but this is an example of what a port knocking may look like. So,
There are special programs that like listen for these things, so you'll have a program that says, okay, I'm gonna wait for agent 22 to come in, and then when that happens, I'm going to open 21. It's not something that's like built into the operating system, like you would write or use a program to do that. It's like having a secret door, or like having a special lock that you want to door for somebody to open.
One thing to note is if you're doing, if you're trying to do port knocking, don't use multiple ports in the same scan, because I learned this last year. It doesn't go in sequential order that you list it, it just randomizes it. So I was like, why isn't this working? So do like 3 individual ones in this case. Don't do like port 80, 21, or 22 and 21 on the same line.
alright, so NMAP actually is a scripting engine. This is a little bit more of an advanced feature, but if you feel like you want to be cool and be one of the hacker kids, you can go make one of these, put it on your GitHub and stuff. So other people have made certain types of scripts to scan for certain things. So like Hartley, which happened in 2013, you can scan for that type of vulnerability. You can check for SMB vulns on a Windows host, or you can do a -- script, non-intrusive. So it'll take all the scripts that are not actually intrusive and run them against the box. So things like that would be running an Nmap scan, checking what type of scan, banner grabbing and stuff like that. It won't actually try and do analysis to see if a service is vulnerable, because that's intrusive. Alright, so let's get some evil bits going. Alright, so again, the big red text at the bottom. Highly illegal, don't do it. But you're at your own risk. So, SYN flood attack. So it creates a half open connection. So basically what we're doing is we have a server that we want to attack, and we just send it a SYN flag. So what does that do on the other end? He goes, all right, I'll accept your SYN flag, we'll open up a connection, and then you won't send anything else, and then he'll just sit there waiting, and waiting, and waiting, and now no one else can use that because he's going to wait for your reply, but you're never going to send it. And then you're going to send him another SYN flag. And he's going to accept it, and then he's going to be waiting, and still waiting on the other one. There is a timeout, roughly, changes on the operating system. I think it's 60 seconds to Linux. Roughly, 60 seconds or 2 minutes. So, with HPing, we can send 10,000 packets, and we can send it from a random source, so we get all these different IP addresses that really may not exist, or may not be actually attacking the box, sending all these SYN packets to the server. So this means when we fill up all the available ports with these SYN floods, that means anyone who's trying to make an actual connection doesn't have an actual port to connect to, because they're all taken up. Alright, so then we have a DDoS attack. So we have an ICP flood attack, which just sends a bunch back.
The SYN flood attack. So I'm making a SYN flood attack, and is there some way in the operating system that if I don't receive an ACK for some time, then I can close that service?
Yes, so automatically built into the operating system is a time, but I think usually for Linux it's about a minute, and for Windows it's escaping me. So you can set that time somewhere in the configuration, but they're all default times. But if you do it fast enough, you can build up.
So there are built-in mitigations for syntax. They're called SYN cookies, and what they do is they embed part of the connection information into the connection itself, so it does not have to maintain an open state. So if you need to protect against a SYN attack, you should look into SYN cookies and how to implement them. The Linux kernel has them by default, and they're very easy to enable.
All right, so ICMP flood attack. So how this works is you're sending a bunch of ICMP requests, which are pinged, to a server, and you're saying it's coming from this IP address, but that IP address is not actually sending it to you. So you're just making up a fake source address. So the server takes in these ICP requests and it sends it out to what it thinks is the client that sent them initially. The client will pick up these packets and go, what the hell are these, and drop them. And then the server's like, where's my reply? I'm not getting anything back. What an asshole, right? So it's going to keep going. So that's part of the ICMP flood attack. Then we have the ping of death. So the ping of death is kind of fun. So these are a bunch of flags that you can set in the TCP, and they all stand for different things. But what you need to know is we're we're creating a connection, we're doing an act, and then we're resetting the connection, all in one TCP flat, all in one TCP connection, which doesn't normally happen. All right, so that's why this works, is it's a malformed packet, and the computer doesn't really know how to handle it, because it's saying, do all this, but you can't do that all, you're doing it separately, so. Here's some resources and sources if you want to read up more on how these tools work. Cloudflare has DDoS protection. I included a link on how to mitigate DDoS protection and how they do it, if you're interested in that. So, any questions? This is my favorite meme of the week.
So Nmap has, you gave it a D flag, but the bullet point just is 120. I don't know if that
Nmap?
Yeah, right here. Just says D120.
Good question. I'll go look that up. I'll fix that. Sorry. Any other questions? All right. One other thing. So Brad's going to go over the demo from last week. So if you guys want to know how the challenges were solved, he's going to go over them all right now. After Brad's done, we're all going to go upstairs to Second Lab 2410. We'll just make this in.
Yeah, do we have the scores up yet?
The scores will, so we had up until 12 o'clock to submit them. So we're going to go through it this weekend and over the next week, and we'll update the scores on the website.
You got it, right? But like, very much not the right way. I'm really good with I didn't really have a lot of time to get into it, but I got like 2 weeks ago, but then I had to work on my
So for the demo, the first 2 flags were flag file and flag process fund. Those were 2 flags we could got into the following new little bash program that I had written. We started off at here's a little tutorial. And you can just go through that and get using bash. So that was the first 2 flags. So then we have some more ones. We have find me, which is a fun one. So you guys get out of this. Did you make that bigger? You don't see that in the back, or should I make that bigger? Bigger. All right. Control plus. Yeah. There you go. Great. As a find me, there's a directory inside of here. What is it? Yeah, so if you go to what is here, there's a lot of stuff. Yeah, let's look through all this. Okay. 0. Oh, there's more. Let's go through each and every one of these individually. No, let's not. So you can just, a little trick you can do is you can ls every single one of these. And yeah, it does that. So that doesn't really work usually, but you can also do a command which is called find, which is really nice. It'll tell you where stuff is on the file system. So you can find flag stars. Instead of these start with flags, you can find anything that starts with flag and ifriendly for things that is slash.
Yeah, flags, all the flags are in capital.
Yeah. So you're represented with the flag by using the find command. Now, let's see. The next one is open files. So if you remember the process from earlier inside of the bash demo, so you have this little process fun flag right there. If you were paying attention to the demo, you would remember a command called lsof, which when combined with the -p flag, you can use the PID for this program, which is 2615, the second column. 2615. And then you will see that there's a suspicious little open file right here that the program has open. So you can use that to see what kind of files a program is going to be writing to, et cetera, et cetera. It's very useful when you need to see what a program is doing back and figuring out what the code. Next one is secrets. So if you go back through the demo again, I had a little bit of fun extending stuff from the demo for this. So in the demo, you get thrown into a directory structure like this one, and if you look, there's a flag right there, so you get that one through it. However, one of the flags says that there may be more of this than appears. One thing that is in Linux is a thing called hidden files, or if you add a dot, if you add a period in front of a file, it does not normally appear. So for example, if I do ls in this, you'll see I have a flag, but if you do ls-a, which shows you hidden files, oh look at that. See your file. A lot of stuff is hidden that way. It's very useful, and you can find a lot of configuration files that are useful with that. Next one is backtrack. Keep going. Cool. So we got another one, dash back, which is a little fun. This is a legitimate backdoor that you can use. You will see a lot in red team and blue team activities. So if you change into the root directory for your user, so if you just hit cd. Does someone have a question? So if you change it to the root directory for your user, if you do ls, you'll just see all your usual stuff, right? But the hidden files I just told you about, there's a whole bunch of fun ones that start with .bash. So those are stuff that bash calls whenever it runs and starts up. So bash RC is called whenever it starts up. So if you edit bash RC and put some not so nice stuff in it, there. So, if you look at these lines down here, I'll try and highlight them for you. So right there, you'll see a flag, and it's also right over a neat little command. It starts up a little socket that sends me your user group permissions. So this is a legitimate thing. Every time you run dash, this file gets called, that command gets executed. You will see this all of the time in CTFs. Pay attention to this sort of thing and be very wary of it. The next one is going to be history. So there's another one of those fun command or fun files, which is .bash_history, which tells you stuff that the person before you has run. So you can edit it and see what people have been doing on your system while you're away. Look at that. The first command is someone setting the password for a user in clear text. You will see that too. It's stupid. You'll see it. All right. Okay, so the hard ones now. So the next one is services. So a lot of times in the services, so a lot of processes will be running the services. So they are the system things like Apache, MySQL, etc. They have dedicated system files in the /sc/image directory. So these get called whenever it's running up Apache and such. So for example, if you look at Apache, it's just a plain web server. If you keep going down, fine. But if you go to the very bottom of the file, it has a ton of white space to hide it, but it has a little bit of a fun shell at the bottom for access. Again, that white space trick also happens a lot. I saw it trip up several people on this demo. It's kind of hilarious, but don't feel bad about it. A lot of editors don't show the white space. Use one that will show you when there are actually lines instead of lack of lines, basically. And then we go to the fun one. So the final challenge is got root. So for this one, you have to find a file in the root directory. You don't have root. How are you going to do it? So if you start playing around with the system, you will notice that there might be one command that is a little screwy. Cat. You shouldn't be able to do this as a non-root user. That should be a little tip off because if you look at permissions as a shadow, you'll see right here. Right there. So if you can see that it is owned by root, which means people who are not root should not be able to read this file. You are most certainly not root. So if you investigate it a little bit, and if you're not familiar, ls-l shows you a little bit more information about the file. So files are nice to have what's called metadata attached to them. So that's basically who is allowed to use this file and what is the file allowed to perform. So if it's allowed to be read, written, executed, and whom is allowed to do that. So if you ls-l/bin/cat, which is the utility for reading files, you'll see this bright red text appear, which is bad. Of course, thank you, CSI Cyber. Now you'll see the interesting permission here is this little S. That's the sticky bit, which means that when that is set, when you run the program, you are given the permissions that the program is currently running with. Since I stickied it as root, when cat runs, you effectively have root permissions, which is great and all, except you can't write files in cat. So what are you going to do? Well, if you look in the root directory, oh no, you can't. Can any of you guys think of a way that you can maybe figure out what files are in the directory without reading? Yeah?
Would you run the cat and like pipe it with the ls root?
No, that does not work. That was very specifically what I was trying to go for is when you're running cat and you're piping it like yes, so when cat executes it'll cat the file, but then when you pipe it, it goes to another program, so you lose the permissions. So that means that you can't just cat to the end of like,
you pipe another command if you have
you can't, there's no piping because you have root permissions only for the duration of the cat command. Can you what?
Command substitution.
What's command substitution?
Running commands instead of commands.
I mean,
subshell you mean?
a subshell wouldn't work for this type of thing because that executes in a different context.
Subshell would actually set up a whole new shell.
Yeah. A subshell calls sh-c, so it's not even operating in bash. So if you want a little trick is the very files I was showing you earlier. Those exist inside of every single one. cat/root /.bash _ history will show you my incredibly convoluted setup process for this demo. If you just read the top of it, so we'll type it to head-n10. So I failed miserably at that. Yeah, so you do to grep. So if you're looking for stuff in the root directory, you can look for roots. touch root/flag.text, vim root flag.text. That might be a little suspicious. Got root?
What's how we did that?
Yeah, so a lot of people have this really creative solution of booting it into another line of distribution that's dirty as hell. Please don't do it again, because I can't stop that without having to make a full VM, which would take the distribution from 2 gigabytes to 20 gigabytes. It's hilarious to you guys, and I love that. That is amazing. But they did. I cannot really protect against that, so please try not to make a habit of that. You won't learn too much from the demos if you do that all the time. But I seriously do appreciate that. When I heard about that, I lost it. There are no rules. I didn't see the options that never came to my head. Like, you definitely can do it into live CD, but that defeats the whole purpose of me setting up a demo for you, which is to learn these tricks, like the fact that dot history exists in everyone's files and it's going to be ranked. So I hope all of you enjoyed the demo. I welcome feedback, positive or negative. I can't make this better if you guys don't tell me what you like or don't like about this.
All right, so everyone is one big group. Everyone gets that. Sorry for the long presentation today, but we have a lot of good content to give you guys, and it's really important that you guys hit the ground running. So we're all going to go up to lab 2410, what we were in last week, and we're going to do the demo. It's all ready on your desktop, ready to go. So let's get it done. Awesome. If you have any, if it persists, let me know. It's a file that I can't fix.
I remember it after us.
Yeah, no problem.
Go right ahead and tell me that. Yeah.